of cylinders, extra examples. Real life application. How much salsa is missing from the jar? In this one, we need to consider that we're finding the empty space here, so we need to know how tall that section of the jar is. We can figure this out by taking this 10 centimeter height and subtracting 4 centimeters of salsa, giving us 6 centimeters of empty space. We are going to find the volume of that empty space. Since that empty space is in the shape of a cylinder, we're going to use V equals pi r squared h. The radius of the cylinder is 5 centimeters. The height of the cylinder that we're interested in is 6 centimeters in height. Don't necessarily need that. The volume, therefore, is going to be pi times 5 squared times 6. And then with the calculation on that, pi times 5 squared times 6 on my calculator, it comes out 471.2388. I'm just going to round it off to that, 0.2. That's centimeters cubed. And that is the amount of empty space in that jar. Next example. A cylindrical water tower has a diameter of 15 meters and a height of 6 meters. About how many gallons of water can the tower contain? Now this problem does not have a picture. It doesn't necessarily need a picture, but if it can help you do the problem, drawing a picture is not a bad idea. This water tower is 15 meters apart and 6 meters tall. Okay, because this is a multi-step problem, and because we do have to find the volume before we can find out how many gallons are in it, we do need to use the volume formula. So volume in this case, since it's a cylinder, pi r squared h, r is 7.5. That number comes from the diameter of the cylinder divided by 2 will give me the 7.5. The height of this cylinder is 6. Okay, now let me change that to blue. The height of the cylinder is 6. Okay, plugging in the information, V equals pi 7.5 squared times 6. And that comes out to be 1,060.287. I'll just go 0.29. I'll round off a little bit more when I get to the end. This is not the end though, because this is the number of cubic meters. The problem does not ask for the number of cubic meters, it asks for the number of gallons. It does give us this handy piece of information. So we're going to set this up as a unit rate problem. If you are unsure whether to multiply or divide when doing a unit rate problem, you can always set it up as a proportion, which is how I'm going to demonstrate it here. So setting this up as a proportion, 1 cubic meter is the same, approximately the same, as 264 gallons. Okay, that's the information given as the basically the scale conversion factor. Now we don't know how many gallons, so that's going to be X gallons. And the cubic meters we know is 1,060.29 cubic meters. And then the reason you want to write these units is so that you can make sure everything lines up. Meters cubed on top, gallons on bottom. This proportion or this fraction comes from the conversion factor. This fraction comes from the numbers in the problem. So if we cross multiply here, you'll see 1 times x and 264 times 1,060.29. So we do end up multiplying. If you already knew it was going to be multiply because you've got your proportional reasoning skills under control, then you're completely okay with just multiplying without needing to do the cross product. Let's see, I'm going to round to the nearest full gallon. and I get 279,917 gallons for the amount of water that that water tower would hold when full. Okay, one more example. This one, another multi-step problem. A square bell is in the shape of a rectangular prism. Square bells are 1.5 feet by 1.25 feet by 3 feet. By the way, the use of the word square here isn't referring to the shape square, but the adjective square, which refers to things having right angles or being rectangular in shape. Anyway, how many times greater is the volume of the round bell pictured than the square bell that was just explained? Okay, the square bell, for this we're going to have to find the volume using a formula we learned back in 7th grade, base area times height. Here the base is, let's just call it 1.5 feet by 1.25 feet. That's the shape of the rectangle that makes up the end of the bell, and that makes 1.875 for the final area. The height is 3 feet. So this is 1.875 times 3, which will give a volume of 5.625, and that would be cubic feet. Okay, now we may have forgotten what we were working on. Remember, go back and reread the problem if you need to. A square bell has the shape of a rectangular prism. All right, we found the volume of a square bell. And we want to know how many times greater the volume of the round bell is, so we need to find the volume of the round bell. Go ahead and change colors here. Since it is a prism, it's pi r squared h with an r of 2. If you're unsure where that 2 came from, that 4 is all the way across, being the diameter. The radius is half of that, so we do get 2. The height is 5. So this is pi 2 squared times 5, which comes out to be 68, whoops, that's a 2, 68.83, or I said that wrong, 62, oh, it was 62. I said it wrong and then wrote it right. 62.83 approximately square feet, cubic feet. Then it is asking for how many times greater the volume is. When you're making a ratio comparison, I want to know how many times greater the round bell is, so I'm going to need to take round bell divided by the square bell and see what that comes out to be. So round bell 62.83 cubic feet, square bell 5.625, and this comes out to be about 11. 11.2 times. So it's 11.2 times the volume, and assuming same density, that means it would weigh over 11 times as much. So you're probably not going to be lifting one of those up, even though you might lift up a square bell.